All right, my friends, today we're going to start our time with a Kahoot game. I know you can't actually play because this is a recording, but you can follow along and try your best. So here we go. Test yourself, see if you can get these correct. There will be 9 questions total. I know this may be difficult to read. This is side A, B, and C. A, B, C. For the sake of giving you time to solve, I will be letting the clock run all the way out before I answer. All right. The answer was C. C is the hypotenuse. Number 2. What is the Pythagorean theorem? We've went over this recently. Double check your answers. Maybe look at your notes. Nothing wrong with that. 20 more seconds. Give it your best shot. You got this. Pythagorean theorem is a squared plus b squared equals c squared. Remember, a and b can be either of the two sides as long as c is the hypotenuse. And look at that, I'm still in the lead. Wow. Okay. What side is the adjacent side to angle A? Don't worry about the words alpha. They just labeled the angle with that letter A for alpha. But basically, which side is adjacent to this angle right here? Again, this is A, B, C. A, B, C. Remember, to be adjacent, for a side to be adjacent to an angle, it's the side between the angle you care about, in this case, angle A, and the right angle. Number 4. What side is now opposite to angle A? So side A was opposite to angle A. Remember, a triangle has three sides, right? And two of those sides are always touching one of the angles. So the opposite side is the side that that angle is not touching. Racking up the points. All right. If you're given the opposite and you're given the opposite and hypotenuse, which formula do you use? Is it SO, CA, or TOA? This should be very straightforward. It's in the name SO, right? S for sine, O for opposite, H for hypotenuse. If you're given the adjacent, very similar to the last problem, now you're given the adjacent and hypotenuse, what formula do you use? Mm. 10 seconds. It's going to be cosine, ca. C cosine, A adjacent, H hypotenuse. How can you tell which one is the hypotenuse? Now be very careful. One of these answer choices is deceivingly true. The other is definitely true. I would say the deceiving answer is subjective. It's something that different people may have different opinions on. Take a look at this triangle, and you might know what I'm talking about by looking at it. So, how can you tell which side or which one of these options, I should say, is the hypotenuse? Hey, if you said it always looks like the longest side, well, that's subjective, right? The triangle, the two sides, one might look a little longer than the other, but you can't go off that. Most mathematicians aren't artists, and it may not be drawn perfectly to scale. But what you do know for sure is that the hypotenuse is always across from the right angle. It's the opposite of the right angle. And we have two more questions. This is true or false. When using a calculator to solve trig ratios, always make sure your calculator is in degree mode. So, should your calculator be in degree mode when using those trig ratios, which are SOHCAHTOA? And the answer is yes, yes, yes. You do want your calculator in degree mode. Make sure you check that no matter what kind of calculator you're using. And last but not least, question 9. Trig ratios can be used to solve for side lengths and angles in any triangle. Read that again carefully. Okay, this is going to be false. Do you know why? Well, we've gone over it. Hopefully you remember that SOHCAHTOA only works with right triangles. It doesn't work with all types of triangles, right? There's isosceles, obtuse, acute. There's lots of different types of triangles, but SOHCAHTOA specifically works with right triangles, not just any. And look at that. I got every question right and ended up in first place against myself. What an accomplishment. All right. Well, hopefully you learned something or at least refresh your memory on some things. Now it's time to go ahead and move forward with the rest of our lesson. So let's do that right now. Need a moment to share the screen here. There we go. All right. So this lesson today is all about degrees and radians. And our goals are quite a few. Convert from degrees to radians and vice versa. So there's helpful little formulas for that. We're going to go over the definition of radians. Determine the quadrant in which an angle in standard position lies, whether it's in radians or degrees. Determine the measure of a central angle given the length of the intercepted arc and the circle's radius. I know these are very wordy, but maybe you can start to visualize. Like you have your axes, you have the central angle, okay, and you have a, let's do this with a pen instead. So for example, here you have your angles are always in the center, right? And it's saying you have a line here that causes an arc there. Here's your angle. We don't know, so it's theta, right? Here's your arc. It's saying be able to figure out that angle, determine the radius of a circle. So remember, radius is a distance from the middle to the outside, given the length of the arc and the central angle. So sometimes you're given the arc and the central angle, and you're asked to find the radius. And then solve problems using the formula for the length of the arc. So we're going to look at a formula there today. So remember, the bigger picture in this unit is discovering the unit circle, what it is, how it works, why it works, and using it to help us answer questions. Okay, eventually that goal is by the time you see it, you know how it works, and you can use it to quickly just answer questions by looking at it. How many degrees are in a circle? So notice here, 0 is right here. That's where we start. And if you go around, you notice we're going in the counterclockwise direction as we're counting up in these degrees. And one full time around is 360. If you skateboard, snowboard, something like that, this is all very familiar to you. Some of you know I skateboarded when I was younger, and I still like to watch. So, where are these angles though? We see them out here, but is this where they actually are? They're actually in the center. But could you imagine all of this being crammed into this little space here? Yeah, that would be very difficult to read. So we list them around the outside. The most important ones is at the quarters, 90, 180, 270, 360. But all of them will be used at one point or another. Now, we've talked a lot about the unit circle, but what makes a circle a unit circle? It's all about the radius. If the radius is 1, that's a unit circle, and we care about it because a lot of interesting and helpful things happen when you have a unit circle with a radius of 1. We also hopefully remember the formula for the circumference of a circle. And we just said that for a unit circle, the radius is always 1. So that means the radius, or sorry, the circumference, the distance around the circle is 2 pi. Well, we call that radians, okay? So you could say 1 full time around the circle is 360 degrees. It's also 2 pi radians. So radians, you might want to write this down, like pi. Radians like pi. So when you see pi measurements around, that's going to be radians. And what this means is that 360 degrees is equal to 2 pi. Those are the same measurement, the same distance around the unit circle. Now, just to elaborate a little bit more on what a radian is, it's an angle that measures, well, let's just start from the beginning. An angle that measures 1 radian, so there's our angle with 1 radian, intercepts an arc length that is equal to the radius of the circle that contains the arc. So this is very special. We have 1 unit radius, 1 radian angle, and 1 unit arc. That is a radian, okay? And if you go ahead and you multiply that, multiply 2 of those times pi, you will get the entire distance around, like we just said a moment ago, which is 2 pi. Alrighty then, here is a more filled-in unit circle with all of the degrees and radians. Notice halfway, remember this is always where you start when you're calculating radians and degrees, and you move in the counterclockwise direction. If you go a quarter of the way, well, that's half of pi, right? Because maybe think about this backwards. If all the way around is 2 pi, halfway around is pi. So from here to there, half of pi is, well, 1/2 pi, or just pi over 2. And then this would be between 1 pi and 2 pi, so 1.5. But you usually see it written as an improper fraction. So we have 3/2 pi there. And then, of course, everything else in between. Now, one of our goals earlier was the first goal I read, if you recall, is to convert from degrees to radians and radians to degrees. These are the 2 formulas. So degrees to radians, you multiply by this, and radians to degrees, multiply by this. Hopefully you just have that in your notes, and I'll give you a moment to write that down. Pause the recording if you need more time. But one way to think about it is like this. If you're converting from radians to degrees, and you know radians like pi, which means your degree answers won't have pi, would you have to put pi in the numerator or denominator here for pi to go away? Well, it has to be in the denominator. So that's one way to help you remember. The pi's will cancel out, like we just said. And 3 goes into 180, 60 times, multiply across, you get 240 degrees. Okay. Now, let's convert from degrees to radians. That's exactly the opposite, or you could say the reciprocal fraction. Again, see if these have a GCF, and they do. 60 goes into 120 twice and 180 3 times, right? 6 times 2 is 12, times 3 is 18. So you get 2 pi over 3, also known as 2/3 pi. take a moment now to go ahead and solve the rest of these. Okay, let's work them out. And notice something interesting. Negative degrees and negative radians. Interesting. We haven't seen that yet, but we will. So multiply here. Here, I'm just setting these all up first to remind myself what I multiply by when converting. That should be pi on the bottom. There we go. And what do we do? Okay, here you're going to get negative 225 pi over 180. And if you divide those, you're going to find out that this simplifies. You could just use your calculator to a negative 5/4 pi. You could do the same thing here. 300 pi over 180. Do 300 divided by 180 on your calculator. You'll get 5/3. And like I said, with the radians, you're always going to see fractions. On your handheld calculator, you can quickly convert from decimal to fractions by hitting math, then enter twice. On Desmos calculator, I actually haven't done that much. Let's see if I can quickly figure out how to do that. 300 divided by 180. I see the decimal. Oh, there's literally a button right next to your answer where it converts from decimal to fraction. That's very nice. Okay, well, let's keep going. Here, again, the pi's always cancel out. 2 goes into 2 once, 180, 90 times, give you 270 degrees. Here, pi's cancel once again. 4 goes into 180, 45 times. And multiply across, you're going to get a pretty big negative number, negative 495 degrees. Also notice, not only is this negative, but that number is bigger than 360. What's going on there? Thinking about that circle, there's only 360 degrees in a circle. How would it be negative? Well, that's going to come. But for now, we're just focused on converting. And this is something we've been doing, but for you to really understand, this is super important. It's not that complex, but it is super, super important. When you're figuring out the angle, whether it's degrees or radians, you always start at the initial side. You could call this the starting line. If you'd like, think about it like you're running a race, you're running laps. And speaking of running laps, you can go around more than once, which starts to hint at what we saw a moment ago, this degree bigger than 360. We'll get there, but for right now, let's just focus on this. For all of these problems in this unit, we're always going to be rotating around the origin, which when we're dealing with these circles is called the vertex. And that just means the angle is in standard position. Okay, so this is the angle here. And this line is rotating around, right? In this case, it just so happens to stop right here. So what happens is you start at the initial side, you rotate around, you go, 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 and wherever that line stops, it's terminated. Done. It stops. And the angle, the interior central angle, is going to be right there. Okay? Now, that is everything you need to know about where to start and the terminology of standard position, vertex, and terminal side. And now things get more interesting. Up until this point, we've said, okay, you start at the initial side, the starting line, you go around in a counterclockwise direction. to get positive angles, and that's true. But there is also such a thing as negative angles, and this is how you find them. You start still at the initial side, but you travel in the opposite direction, aka the clockwise direction. So you'll be asked to find positive and negative angles, whether they be in degrees and radians, and that's how you do it. Now we're going to finish our time today determining the quadrant where each angle lies. So let's start with maybe reminding us where each quadrant is. So take a second, see if you can test yourself and label each quadrant. Hey, my advice to you is always to write the letter C. Wherever you start, that's quadrant 1. Then you go this way, that's quadrant 2. Then this way, quadrant 3, and finally quadrant 4. And yeah, you usually see them written in Roman numerals. So there's the quadrants, and this one, as we've seen before, is between 0 and 90 degrees, 90 to 180, 180 to 270, and 270 to 360. Okay, so 22 degrees falls in this quadrant 1 range. So that's 1, 106, quadrant 2, 205, 3. 310 is in quadrant 4. Now things get interesting. 373. Well, let's see. We know if we go around 1 full time, that's 360 degrees. But like I mentioned a moment ago, you can keep going. So 373 would just be 13 more. So it'd end about there, meaning we're going to end up in quadrant 1. And negative, we've talked about negative degrees today. That means you go in the clockwise direction. So if positive 75 takes you about here, negative 75 would take you about here, meaning you'd be in quadrant 4. That's it for now. In our next lesson, we're going to dive deeper into this. So make sure you study and understand.